There is a country smaller than New Jersey that for the past 50 years has quietly shaped the way every major military on Earth thinks about unmanned warfare. Not the United States, not China, not Russia. A country of 9 million people, surrounded by enemies since the first day of its existence, that responded to near annihilation not by building more tanks or more fighter jets, but by asking a question that nobody else was asking at the time. What if the most dangerous thing in the sky had no pilot inside it? What came out of that question was a drone industry that today exports to over 50 countries, accounts for more than 60% of all unmanned systems ever sold internationally, and has seen combat in conflicts from the Bekaa Valley to the South Caucasus to South Asia. This is the complete story of every military drone ever built by Israel, and it begins with a catastrophe. The lesson of 1973, how a near defeat built an industry. In October 1973, Egypt and Syria launched a coordinated surprise attack on Israeli positions in the Sinai and the Golan Heights. In the first 72 hours, the IDF lost over 100 aircraft, many of them to Soviet-supplied surface-to-air missile systems that Israeli intelligence had failed to locate or adequately map. The pilots who survived those first days came back with a clear message. They could not fly into defended airspace without knowing where the missiles were, and they could not find the missiles without flying into defended airspace. It was a closed loop, and men were dying inside it. Israel's response was not to build better jets. It was to remove the pilot from the equation entirely. Before the decade was out, engineers at Israel Aircraft Industries had begun work on a small fiberglass reconnaissance aircraft that could go where pilots could not. They called it the Scout, and almost nobody took it seriously. David Harari, one of the project's 3 lead engineers, later recalled that when he first proposed the concept, people laughed at him. In 1981, all 3 engineers received the Israel Defense Prize. The laughter had stopped. Built in 1978, the IAI Scout was a piston-engined aircraft with a 5-meter wingspan, weighing roughly 55 kilograms, powered by a single engine producing 22 horsepower. Its fiberglass frame gave it an almost non-existent radar signature, making it exceptionally difficult to detect. More importantly, it could transmit real-time television imagery from a camera mounted in its central turret to a portable ground station below, giving commanders a live view of the battlefield from an aircraft that cost a fraction of a fighter jet and put no crew at risk. The Scout's first combat appearance was in 1981, when South African forces operated it in Angola during Operation Protea, marking the first confirmed use of a modern reconnaissance drone in combat by any military in history. Its defining moment came a year later. During the 1982 Lebanon War, IDF commanders used Scout and Mastiff UAVs to locate all 28 Syrian surface-to-air missile sites in the Bekaa Valley, feeding their coordinates to Israeli strike aircraft in real time. Operation Mole Cricket 19 destroyed every single one of those sites without a single Israeli pilot lost to enemy fire. Every air force on Earth watched what happened in the Bekaa Valley and drew the same conclusion. The drone had arrived. America comes knocking. The Pioneer and its famous surrender. The Americans were watching from Lebanon in 1983. The suicide bombing that killed 241 U.S. Marines that October reportedly accelerated the U.S. Navy's interest in battlefield UAVs, and by 1984, they had issued a formal requirement. IAI formed a joint subsidiary called Maslat with Tataran, teamed with American manufacturer AAI Corporation, and developed the Pioneer, an upgraded derivative of the Scout with a more powerful Sachs two-stroke engine and the ability to operate from the deck of a warship. The Pioneer entered U.S. service in July 1986, initially aboard Iowa-class battleships. It could carry a 34-kilogram electro-optical and infrared sensor payload, relay analog video in real time over a range of 185 kilometers, and remain airborne for up to 5 hours. The U.S. Army, Navy, and Marine Corps all operated it, and it flew in the Gulf War, Somalia, Bosnia, Kosovo, and Iraq before its final U.S. retirement in 2007. Its most famous moment came in February 1991, over Failaka Island near Kuwait City. A Pioneer launched from the battleship USS Wisconsin was conducting battle damage assessment after naval gunfire from the USS Missouri when Iraqi troops on the island, hearing the drone's unmistakable two-stroke engine overhead and knowing what came after it, began waving white flags at the aircraft. Marines landed and collected the prisoners. It was the first time in the history of warfare that human soldiers surrendered to a robot. When the U.S. Navy later offered a Pioneer to the Smithsonian Institution, curators specifically requested the aircraft that the Iraqis had surrendered to. That particular Pioneer is now on display in Washington. The reconnaissance generation, Searcher, Heron, and the architecture of persistence. The Pioneer proved the concept. The IAI Searcher, entering service in 1992, built on it. Larger and more capable than the Scout, the Searcher was designed for sustained tactical surveillance at ranges beyond what the earlier platform could manage, and it became one of IAI's most commercially successful export products. India became a major operator, deploying large numbers of Searcher drones along its Pakistani and Chinese frontiers for persistent border surveillance, and the Searcher Mark II extended both range and endurance further, giving the platform a service life that stretched across 3 decades. But the Searcher was a stepping stone. In 1994, IAI flew the first prototype of something considerably more ambitious. The Heron, designated Makats 1 in Israeli service, was a medium-altitude, long-endurance platform designed not for hours of flight, but for days. Powered by a single Rotax 914 engine producing 115 horsepower, it could carry up to 470 kilograms of payload, operate at altitudes up to 10,500 meters, and remain airborne for over 52 hours continuously. Its avionics included an internal GPS navigation system with fully autonomous flight capability, Q-band satellite communications for over-the-horizon data relay, and sensor options ranging from electro-optical cameras to synthetic aperture radar to electronic intelligence equipment. The Heron entered operational service in 2005 and within a decade had been adopted by more than 15 countries. Germany, France, India, Canada, Australia, Singapore, Brazil, Morocco, and Turkey all operate it, with France flying a derivative called the Harfang extensively over Afghanistan and Mali. IAI estimates the Heron family has accumulated hundreds of thousands of operational flight hours combined. At a unit cost of approximately $9.5 million, it occupies a critical price point between cheap tactical drones and the far more expensive American Predator and Reaper systems. Then Israel decided to build something bigger, something that could reach Tehran. The Heron TP, designated Eitan, meaning steadfast in Israeli Air Force service, first flew in 2004 and was publicly unveiled at Tel Nof Air Base in October 2007. Its wingspan is 26 meters, comparable to that of a Boeing 737. It is powered by a 1,200 horsepower Pratt and Whitney PT 6A-67A turboprop engine in a pusher configuration. Maximum takeoff weight is 5,300 kilograms. Payload capacity is 1,000 kilograms. Service ceiling is 45,000 feet above commercial air traffic. All flight avionics are triple redundant. Endurance exceeds 36 hours in documented configurations, with some sources citing figures above 70 hours. Entered Israeli Air Force service in February 2010 with the White Eagle Squadron at Palmachim Air Base. The ATAN was reportedly used in 2009 in an airstrike targeting an Iranian arms convoy traveling through Sudan, a mission requiring a round trip of well over 3,600 kilometers from Israeli territory. India approved the purchase of 10 armed Heron TP variants in September 2015. In 2018, IAI signed a $600 million agreement with Airbus to lease Heron TP systems to Germany's Bundeswehr. That contract was specifically written to include a potential strike capability, a detail that Airbus mentioned explicitly in its press release, and that IAI pointedly declined to confirm or deny. The suicide drone, Israel invents a new category of weapon. While the reconnaissance platforms were accumulating flight hours over deserts and mountain ranges, a separate and more radical concept was taking shape inside IAI's weapons division. The question was straightforward. What if instead of sending an aircraft to find the missile battery and then sending a separate aircraft to destroy it, you combined both functions into a single disposable vehicle? The result was the Harpy, developed in the 1980s and entering service in the 1990s, one of the first operational loitering munitions in history. The Harpy carried no pilot, no recovery system, and no plans to land. It was launched from a ground canister, flew autonomously to a designated area, and searched for active radar emissions. When it found one, it identified the frequency, locked on, and dove into the antenna at high speed, destroying itself and the radar system simultaneously. No coordination with strike aircraft required. No human in the decision loop once launched. A single operator could put multiple Harpies in the air over a defended area and wait for enemy radar operators to make a mistake. The moment they switched their systems on, they were already dead. The Harop, developed between 2001 and 2003 and first publicly revealed at Aero India 2009, added a critical capability the Harpy lacked. It put a human back in the loop. Launched from the same type of canister, the Harop carries an electro-optical sensor that transmits live imagery to a remote operator who can identify specific targets, select which ones to attack, and abort the mission at any point before impact. Its 23-kilogram warhead, 6+ hours of endurance, and 200-kilometer operational radius make it a credible standoff strike weapon against air defense systems, radar installations, command posts, and armored vehicles. In April 2016, Azerbaijan deployed Harop systems during the 4-day war in Nagorno-Karabakh, using them to destroy Armenian air defense batteries, radar stations, and a military bus used as troop transport. It was the weapon's first confirmed combat use, and it worked in conditions that included freezing temperatures, shallow terrain, and GPS-jammed zones. In 2020, during the larger Nagorno-Karabakh conflict, Azerbaijan used both Harop and Skystriker systems extensively. Azerbaijani President Ilham Aliyev publicly praised their effectiveness. In May 2025, India reportedly used Harop systems during Operation Sindoor, targeting Pakistani air defense infrastructure, marking the weapon's South Asian combat debut. Then there is the IAI Green Dragon, a different kind of disposable. Weighing just 16 kilograms, It carries a 3-kilogram warhead, has a range of 40 to 50 kilometers, and remains airborne for approximately 75 minutes. It is launched from multi-canister systems mounted on standard military vehicles, with a single launcher capable of housing and sequentially firing over a dozen vehicles. Its electric pusher motor produces a near-silent acoustic signature. Its radar cross-section is approximately 0.5 square meters, making it extremely difficult to detect visually or electronically. If an attack is aborted, it can be recovered and reused. It puts sustained precision, strike capability in the hands of battalion-level ground commanders without requiring an airfield or a dedicated UAV crew. Elbit's answer, the Hermes family, and 300,000 hours of combat. While IAI was building strategic systems, Elbit Systems was solving a different problem. Not how to reach Iran, but how to stay over the target for 20 hours at a cost that any military could afford. The Hermes 450 was developed in the early 1990s by Elbit's Silver Arrow subsidiary and entered operational service in 1998. With a wingspan of 10.5 meters, a maximum takeoff weight of 450 kilograms, and a payload capacity of up to 180 kilograms, it could carry electro-optical sensors, synthetic aperture radar, electronic warfare equipment, and optionally up to 4 Rafale Spike air-to-ground missiles. Its Wankel rotary engine gave it up to 20 hours of endurance and a service ceiling of 18,000 feet. By any measure, the Hermes 450 became one of the most operationally proven tactical drones ever built. It has logged over 300,000 documented combat flight hours. The British Army selected it as its primary tactical UAV for Afghanistan and Iraq. It directly formed the technological basis for the UK-French Thales Watchkeeper WK-450 program. The Israeli Air Force designates it the Zik and operates it from the 161st Squadron at Palmakim Air Base. In July 2021, the Zik was the centerpiece of Operation Blue Guardian, the first international joint drone exercise ever conducted, with Israel, Germany, France, Italy, the United States, and the United Kingdom all flying the platform together for 2 weeks in the Negev. Over 15 countries operate it. Azerbaijan, Brazil, Colombia, Singapore, Thailand, and the Philippines are all current operators. The Hermes 900, designated Kochav, meaning star in Israeli service, flew for the first time on December 9, 2009, and entered operational service in 2012. It is a substantially larger aircraft than the 450, with a 15-meter wingspan, a maximum takeoff weight of 1,100 kilograms, and a payload capacity of up to 450 kilograms carried across internal bays and external hardpoints. Its 160-horsepower Rotax 916 engine supports sustained operations up to 36 hours at a service ceiling of 30,000 feet. Payload options include electro-optical and infrared sensors, synthetic aperture radar with ground-moving target indication, electronic warfare systems, communications intelligence equipment, and 4 Rafale Spike missiles. Its combat debut came earlier than planned. During Operation Protective Edge in July 2014, the Hermes 900 was fast-tracked into service over Gaza before IDF ground crews had completed their maintenance qualification. Elbit personnel supported flight operations directly in the field. A few days after receiving the order to deploy it, a Kochav was airborne over the Gaza Strip. Its first operational mission, on July 15, 2014, culminated in an airstrike by IDF fixed-wing aircraft that destroyed a Hamas target, identified by the drone's sensors. In 2018, the European Maritime Safety Agency awarded Elbit a $68 million contract to provide maritime surveillance services over European waters using Hermes 900 systems, one of the first times a non-European company had secured a major operational service contract with an EU institution. More than 15 countries now operate the type, with approximately 200 units produced. Down to the squad, the Skylark family, and the soldier's drone. Every system described so far requires a runway, a launcher, or at minimum, a vehicle. The Skylark one requires none of those things. It requires a soldier with a backpack and enough space to throw an aircraft into the air. Developed through a joint initiative between Elbit Systems, the IDF's Technology and Logistics Branch, and its Ground Forces Command, the Skylark one was designed to give infantry units their own organic airborne reconnaissance capability at the squad level. It weighs approximately 6 kilograms. Its electric motor is nearly silent. A single operator can unpack it, configure it, and have it transmitting live video within minutes of arriving at a position. Recovery involves a programmed deep stall maneuver followed by landing on a small inflatable cushion attached to the underside of the fuselage. The operator does not need flying experience. The Skylark navigates using onboard GPS and can be directed simply by pointing the camera toward the area of interest. It entered IDF service in 2008 under the designation Roshev Shamayim, meaning Skyrider, operated by the Artillery Corps. During Operation Protective Edge in July 2014, every active and reserve IDF brigade received at least 2 Skylark systems and flew them continuously. By August 12th, 35 days into the operation, 18 Skylark systems had collectively flown several hundred operational hours over Gaza, streaming target acquisition data directly to soldiers in the field. The system has since been deployed in the West Bank, Lebanon, and Syria, and has been adopted by over 30 countries, including France, the Netherlands, Poland, Sweden, Czech Republic, Hungary, Croatia, South Korea, and Australia. The Skylark II, unveiled in 2006, scaled the concept up to battalion-level operations. Launched from a rail-mounted system on a HMMWV-class vehicle and operated by a 2-person crew, it extended range to 60 kilometers and added a thermal imager, laser illuminator, and optional laser designator. South Korea selected it in December 2007. The Skylark III, revealed in February 2016, pushed further still, with a 4.8-meter wingspan, a 45-kilogram takeoff weight, a 100-kilometer operational range, and up to 6 hours of endurance. It can be deployed from either a ground-mounted pneumatic launcher or a vehicle system, operates fully autonomously from takeoff to landing, and requires no piloting skills from its operators. 2 aircraft can be flown simultaneously from a single shared ground control station. And then Elbit took the Skylark concept and attached a warhead to it. The Sky Striker is a fully autonomous loitering munition carrying either a 5 or 10-kilogram warhead internally, with an operational range of 100 kilometers and up to 2 hours of endurance in hunter mode. Its electric motor produces a near-silent acoustic signature for low-altitude covert operations. A human operator maintains man-in-the-loop control throughout, with the ability to abort the attack even in GPS and communications-denied environments. Azerbaijan's State Border Service became the first foreign operator in 2019 and used the weapon during the 2020 Nagorno-Karabakh conflict. In September 2023, Elbit announced a contract to supply several hundred Sky Striker units to an undisclosed European country under an agreement valued at $95 million. Beyond the giants, the wider Israeli drone ecosystem. IAI and Elbit are the flagships, but Israel's drone industry extends well. Beyond them, and the systems produced by smaller manufacturers fill tactical gaps that the larger platforms cannot reach. Aeronautics Defense, a company in which Rafael holds a partial stake, produces the Orbiter family, a series of tactical systems ranging from the man-portable Orbiter 1, designed for squad-level surveillance with a hand-launch capability and silent electric motor, to the vehicle-launched Orbiter 4, capable of 4-hour endurance and compatible with loitering munition payloads. The Orbiter 1K variant crosses the line from reconnaissance into strike, adding a warhead to the standard surveillance airframe and giving infantry units a direct-fire precision capability without requiring coordination with higher headquarters or dedicated strike aircraft. The concept is identical to the Sky Striker and the Green Dragon, but packaged for the lowest possible tactical echelon. Bluebird Aerosystems produces the Spylight, a micro-UAV in the 2-kilogram class designed for platoon-level intelligence gathering. Electrically powered, near-silent, hand-launched, and recoverable by parachute, the Spylight is designed for situations where even the Skylark 1 represents too large and too detectable a signature. It has been exported to multiple customers in Asia and Europe, and it reflects a consistent Israeli approach to unmanned systems, which is to push reconnaissance capability as far down the tactical chain as physics and electronics allow. What makes all of these systems collectively significant is not any individual platform. It is the doctrine behind them. Israel does not develop drones in laboratories and then attempt to sell them to militaries that will use them for the first time under fire. It deploys unfinished systems, observes their performance in active combat, refines them in the field in direct collaboration with manufacturers, and then brings a combat-proven product to the export market. By the time a foreign military operator receives an Israeli drone, that aircraft has almost certainly already been used in an actual conflict. That is an advantage that the United States, China, Turkey, and every other drone-exporting nation cannot fully replicate. From a 55-kilogram fiberglass aircraft that helped destroy 28 Syrian missile batteries in a single afternoon in 1982, to a 5,300-kilogram turboprop platform that can reach Sudan and return, to a 6-kilogram backpack drone that a single soldier throws into the air over Gaza, Israel built every rung of this ladder under fire, out of necessity, one aircraft at a time. The Iraqi soldiers who surrendered to a pioneer in 1991 could not have known they were looking at the beginning of something. 50 years of combat, 50 years of engineering, and a country that turned the fear of being blind on the battlefield into the most consequential unmanned weapons program in modern history.